Here are your objectives for section 1.7. Okay, use interval notation, find intersections and unions of intervals, solve linear inequalities, recognize inequalities with no solution or all real numbers as solutions, and solve compound inequalities and solve absolute value inequalities. Okay, so do we see a common thread throughout today's lesson? Inequalities. Okay, so first of all, we need to talk about interval notation. Okay, we did talk about this in Algebra 2 to get you ready for this for today. So, inequality notation and interval notation. INT. Oh, geez Louise. Inequality notation looks like x is greater than 12. If that's what it looks like in inequality notation, we need to remember that in interval notation, this says everything greater than 12. So we start at 12 and go to infinity. We have a parenthesis on the side of the 12 because the 12 is not included as part of our domain. Because if it was included, this would say greater than or equal to. Remember that? Okay. On a number line, what would it look like? Here's 0, here's 12. What would it look like? So an open circle or a parenthesis. Remember, it's an open circle or a parenthesis, and it would be greater than 12, so it's facing this way. Okay? What if it said x is greater than or equal to 12? What would the interval notation look like then? It would be a bracket, right? 12 to infinity. And how would the number line be different? It would be a closed-in circle or a bracket on 12, also shaded to the right because that's where it's greater than 12. Yes? 2 is less than or equal to x is less than 4. So if we have 2 is less than or equal to x is less than 4, interval notation, it's going to go from 2 to 4, right? And what's around each one of these? Bracket on the 2, parenthesis on the 4, right? Because the 2, its x is greater than or equal to 2, and the 4 is just less than. Okay? So on the number line, we've got a 0, we've got a 2, we've got a 4. So on the 2 would be a bracket, 2 a parenthesis on the 4. If we were doing circles here, we would have a closed circle on the 2 and an open circle on the 4, shaded in between the two numbers. Does that make sense? So if we have negative 2 is less than x is less than or equal to 8, what is that going to look like in interval notation? From negative 2 to 8, good, parenthesis on negative 2, bracket on 8, good. Number line wise, we would have a parenthesis on 2, just like the interval notation, right? And a bracket on 8, just like interval notation. Shaded in between. If we were using open and closed circles, we would have an open circle on 2 and a closed circle on 8, shaded in between. Does that make sense? Intersections and unions. Intersections and unions of intervals. Now, in the prerequisite chapter, you did some problems on intersections and unions. So let's talk about when we're talking about domains right here. Okay. Now, in the beginning of talking about intersections and unions, for some people, it's way easier to see on a number line. So I'm going to draw number lines for you. Okay? So what I want you to remember first of all is that this means intersection. Okay? Intersection is the one we did not use in Algebra 2. Union was the one we used in Algebra 2. Okay? So let's start right here. I've got 0, 1, 2, 3, 4, 5, 6, 7. I didn't give myself enough room. 8. Okay? So what does the graph look like from 1 to 4? Well, here's 1. 1's not included. Neither is 4. But it looks like that, right? So this is the one that is 1 to 4. Okay? What does 2 to 8 look like? 0, 1, 2, 3, 4, 5, 6, 7, 8. So 2 is here. 8 is here. That's everything between, right? So the intersection means, what do they both have? Okay, so on this number line, 0, 1, 2, this is going to be my answer. 2, 3, 4, 5, 6, 7, 8. It's like here, right? Because that's what they both are. Yes? Is the 2 included on both number lines? Yes. So I got a bracket here. Is the 4 included on both number lines? Yes here, not here. So I cannot include it as part of my answer. That is the answer. Now, what does that look like in interval notation? Well, because we drew this already, it's pretty easy, right? From 2 to 4. Does that make sense? Okay, so what if we were doing this problem? 1 to 4 union 2 to 8. So it's all 1 or the other or both, right? U is the union. Includes everything that one or the other or both have. Okay, so I've already got both of these two parts drawn up here. So can we just use that again to help us write our answer down here? Okay, 0. Oh, look what I did. Nobody even said anything. That should be a 1. There's typically not 2 2s when you're counting. 3, 4, 5, 6. If you're paying attention, there's not typically 2 2s. Okay, so how far, if we're looking at the top 2 right here, the top 2 number lines, how far to the left does any of them go? And is 1 included? No, so 1 can't be included in the answer. And how far to the right does either of these go? To 8, right? And everything in the middle is included, isn't it? Because it's one or the other or both. So that's from 1 to 8. Does that make sense? Any questions about unions or intersections? So next is solving linear inequalities. Okay? Solving linear inequalities. So here we go. 3 minus 2x is less than or equal to 11. So to solve this linear inequality, what do we do first? Yeah? So negative 2x is less than or equal to 8. And now, we have to remember to flip that inequality sign, right? Why is that? Because we divided or multiplied by a negative number. Remember that? Good. What's the number line look like for this answer? Closed on negative 4. To the right. Got it? What about this one? Oh, we're done with that problem. Is it okay if I go into a new one? Okay. So x plus 5 is less than x minus 4. So what's first? Subtract x. Okay. 5 is less than negative 4. Yeah, because is 5 ever less than negative 4? No solution. Because the next one says recognize inequalities with no solution or all real numbers, right? Okay. X minus 4 is less than x plus 5. If I subtract x from both sides, I get negative 4 is less than 5. Always? Always. That means it does not matter what I put in for x. It will always be true. Any value that I choose for x will always be true. Any value that I choose for x will never be true on this one. Okay? But any value I choose for x, it will always be true. Okay? Compound inequalities is something I'm not sure if you've seen before. Okay? So I would like to show you some compound inequalities. And they could show up in different ways. So I'd like to show you 2 different ways they could show up. Okay? First of all, they could show up like this. Negative 3 is less than 2x plus 1, and 2x plus 1 is less than or equal to 3. It's a compound inequality because there's actually 2 inequalities, right? But it's joined together by this word, which means you know it's part of the same problem. Okay? So I need to start on the left and solve the left one. So subtract 1, subtract 1. Negative 4 is less than 2x. Divide both sides by 2. Negative 2 is less than x. That's all the way solved, isn't it? So I need to go to the other side. Solve this other side. Subtract 1, subtract 1. 2x is less than 2. If I divide both sides by 2, which I need to do to isolate my x, I get x is less than 1. Because this is an and, we can graph them on the same number line, right? So I've got negative 2 here, and I've got 1 here, which means 0 is like right there, right? So x is greater than negative 2. Can I fix this real quick? I just forgot to drag the or equal to along. Thank you. X is less than or equal to 1, so this is definitely a bracket right here. And then because it's greater than negative 2, it shade to the right. Because it's less than 1, I shade to the left, so I end up shading in between them. Okay? Is that what you were asking? Okay, good. Here's another way it could show up. Negative 3 is less than 2x plus 1 is less than or equal to 3. When we solve equations, do we have more than one equal sign ever? Nah, we don't, do we? But when you're solving inequalities, it can show up like this. So if I say I subtract 1 from both sides, there's not just both sides anymore. Do you see that there's like 3 sides? So if I subtract 1, I had to subtract 1 here and 1 here. Does that make sense? So on the left-hand side, I end up with negative 4 is less than 2x is less than or equal to 2. Now when I divide everything by 2, I'm going to divide everything by 2. So negative 2 is less than x is less than or equal to 1. Isn't that exactly the same thing as this up here? This was just written into 2 different parts and an and was in between. But if it's all written as one sentence, that and is implied, isn't it? So when I go to graph it, it's going to look the same as the one I just did. It's just a matter of like how the problem was asked. Does that make sense? It could be asked as 2 separate problems, or it could be asked as one problem. This kind of compound inequality. Okay? So all that's left is absolute value inequalities. Remember doing absolute value inequalities? Well, whether or not you remember it, we did it. Oh, yes? Okay, good. So what about this? Negative 2. Absolute value of 3x plus 5 plus 7 is greater than or equal to negative 13. So to solve this first, I need to isolate my absolute value, right? I need to isolate my absolute value. So to isolate the absolute value, what do I need to do first? Subtract 7. So I have negative 2 times the absolute value of 3x plus 5 is greater than or equal to negative 20. Is it isolated yet? Not yet. So divide by both sides by negative 2. Remembering, of course, since we're doing absolute values, that when I divide, since we're doing inequalities, when I divide by a negative, I'm going to flip that sign, that inequality sign, to be a less than or equal to 10. Okay? Now that the absolute value is isolated, what do I do now? I have 2 parts, right? You remember this? I have the part where whatever's inside is exactly what it is, so it's positive value, right? And then I have the other part where whatever is inside is the negative value. Yes? Okay. So I solve these separately. Kind of like I just solved this problem separately, right? Now, there's not an and written, so I can't assume an and. This could be an and or an or, and we'll know that once we get to the end. Okay? So if I subtract 5 from both sides, I get 3x is less than or equal to 5. I divide both sides by 3, and I get x is less than or equal to 5/3. Now, what do you want to do first here? Do you want to distribute, or do you want to divide by negative? Negative 1. Distribute, okay, that's fine. Here and here. That gives us negative 3x minus 5 is less than or equal to 10. So what do I do to solve this now? If I add 5 to both sides, I get negative 3x is less than or equal to 15. Now I divide by negative 3. Remembering to flip my inequality sign, right? X is greater than or equal to negative 5. Now, here's why I have to decide if this is an and or an or. Okay? Let's say I've got negative 5 down here, and I got positive 5/3 up here. Yes? I know by looking at the signs that they are both brackets. I need everything less than or equal to 5/3, which means it's going to open this way, correct? And I need everything greater than or equal to -5, so I know it opens that way. So now tell me, is this an and statement or an or statement? And how do you know that? Because they are toward each other, right? That is definitely an and statement. Okay. Should we do one more? God bless you. One more? Okay, God bless you. So what if we have this? Absolute value of 5 minus 2x is greater than 7. It should bring you great hope that I'm only using this much paper, right? So isolate the absolute value. Okay, done. So now we write it our two parts, right? I say whatever's inside exactly as it is, and whatever was inside, the negative of that, right? The opposite of that. Now solve each of these. So subtract 5 from both sides. Negative 2x is greater than 2. If I'm dividing both sides by -2, x is less than -1, right? Flip the sign, inequality sign. Over here, what do you want to do first? Distribute. Do you have to distribute first? No. You can divide both sides by -1 to first if you want to, right? This particular one I would definitely distribute first because that gets rid of the negative on my x value, right? The negative coefficient there. So -5 plus 2x is greater than 7. When I add 5 to both sides here, I get 2x is greater than 12. So when I divide both sides by 2, I get x is greater than 6. So let's graph it. Here's my -1, here's my 6. X is less than -1. So I know it's got to be a parenthesis, and I know it's got to open that way because it's less than. X is greater than 6. I know it has to be a parenthesis, and an opening greater than opens that way. So is this and, or is this an or? How do you know? Because they are going away from each other. That's exactly right. So that's definitely an or statement. Okay? Any questions?